once you have logged into the platform, you can click on the file and then new notebook in Drive. I'm just mentioning everything very clearly for those who are following. You just have to click on new notebook in Drive and open up a new window that contains your coding platform. So I can just close this previous window and we now have this new one in front of us. This sheet basically we are going to utilize for any kind of coding now that we'll be using with different data sets right here. So the very first thing we are going to implement here is, since we are going to work on different data cleaning, pre-processing and sampling techniques. So following that, we are going to first create the data cleaning procedures, and we are going to understand various aspects of it. So the very first thing, I'm just renaming this as session 1. You all can rename it based on your requirement so that this exact name gets saved in your Gmail Drive and you can access it from there easily anytime in future. Next, we are starting with the first task over here. That will be data cleaning. I'm writing markers for everything. I'll be putting clear descriptions for everything so that you can understand it from the scratch. The first thing is data cleaning, and why we need to do that. This is the main point to understand. For those who are planning to do any kind of field applications with data science, machine learning, deep learning, this data cleaning or data pre-processing part is very much important, because this helps you to understand how clean or how good is your data, what kind of approaches you need to follow to bring this data to the pipeline for your machine learning or deep learning model. Generally, in deep learning, we can process data as a raw form, in the raw form also. But in machine learning, this data cleaning is very much important, because majority of machine learning model cannot handle data set with impurities. They will have very poor accuracy in that case. So that this cleaning process becomes very much important in machine learning. And sometime in deep learning also, you may have to follow a few of these procedures just to enhance accuracy of your system. So we are just talking about data cleaning procedures, and it includes a variety of disturbances that are possible in your data, such as we can have missing values, we can have outliers in data. And missing values may be due to some sensor failures if you are working on the hardware side. Maybe if you are collecting images from CCTV cameras, maybe sometime it was on sleep mode, or maybe power failure occurred, or any other reason, any other failure occurred in your CCTV camera and you were not able to receive certain images for an hour or half an hour. Similarly, for the sensor data, maybe some sensor got damaged, there are some field violations, or some operating conditions got changed. So all those things can lead to missing values. And this can also happen when there is a human error. The person who is creating your Excel sheets, they may have missed something by mistake, or maybe due to some reason. So all these things cause missing values in your data, and they can reduce the credibility of your data. So we need to follow a very precise approach to deal with those missing values. So there are multiple techniques that we can follow, like dropping those rows and columns that have missing values. Imputations, that means we can fill values by using mean, median, or mode, or many other statistical values by using a specific function out there. We have interpolation techniques also that you can use, like linear interpolation or spline interpolation. These are just few examples. Currently, we are going to start with one sample data set over here. What I'm doing is, I'll first create one sample data set. Later on, we'll be using the CSV files that you all have. So I'll just let you know that how you can get those files also from your system to this Google Colab platform. Step by step, we are going to do everything. So in order to create a data set, I'll take help from two libraries over here. First is pandas as PD, and second library we need is numpy as NP. I'm just considering that many of you might be aware of these libraries, but if you need any explanation, just let me know. I can explain everything in detail. I'll just look forward for quick responses in the chat box for everything. This is how we are going to interact throughout all the sessions that I'm going to take in this course. So anytime you can put your queries in the chat box. So pandas we need to handle different types of file formats, and numpy we need for numerical manipulations on data. And now I'm going to create a data set by using dictionaries approach, because I'm just creating a sample data set over here. And for instance, I'm giving it a name, a dict. You can give any variable name, that is your choice, anything you can give. And inside this, dictionaries we always put inside curly brackets. So the same I'm using here. So for instance, first score is one variable that I'm creating here. Dictionaries always have key pair values, and inside this I'm just putting some random values. And you can observe that there is one new thing that I have added. Between some numerical values, I'm adding here np.nan. Since I'm creating data containing missing values manually, so I'm putting these nan values myself. Means they are some kind of missing values that we represent by np.nan over here. So because I'm just trying to create a false data set for analysis right now over here. Otherwise, you will get this automatically from the filled environment. So this observation sequence I have created. For instance, these 12 observations I have inserted. Similarly, I'll create for second score. And for this again, I'll put up 12 more observations. We need to have, of course, same number of observations in all categories. So the same I'm trying to create here. Any random value I'm inserting just to make a sample data set over here. And we will see how we represent it further. You will basically learn to create a data set first, a sample data set, and then you will learn how we clean it up. So few random values I'm inserting here. You can try any value, that is your choice. Otherwise, I'm also going to share this with all of you so that you can try it, you can practice it side by side. First, let me just run it. If it works fine, I'll be sharing with all of you. So some scores I have created here randomly with some nan values in between. And these 3 columns only I'll be creating for my data set. And I'm just putting some random information inside. So these are my values right now. This is a simple dictionary that I'll be converting into a data frame now. This is a data frame that I have created here. So I took help from pandas again. You can see I gave this PD nickname to pandas. And with the help of pandas, I'm converting this dictionary to a data frame. Let me just run this. And if it works fine, we will see a pattern of this data by using next command. So in the meanwhile, I can share this with all of you in the chat box also, so that you can run it and execute it on your system if you are doing it parallelly. So here you find the code in the chat box. So in order to see this code, I have the head function. And this head function basically helps you to visualize first 5 rows of data. So I'll just run it and let us see what we have inside this data. This is the data sample that I just created. Currently, I'm not having any responses in the chat box. So if anyone is implementing and I need to wait for their implementation, I'm not aware of that. If you start interacting in the chat box, I'll keep my speed as per your pace only, because I just believe that this should be useful for all of you.
Actually, chat is disabled.
Yes, please.
Chat is disabled, ma'am, right now.
Chat is disabled, ma'am, from our side.
Okay. So in that case, maybe I'll not be able to have responses from the participants.
Now you should chat all.
I will enable, ma'am.
Okay,
I will enable.
Okay, that's great. So I'll just request everyone, just put your messages side by side in the chat box, because if you interact, then only I'll come to know if you have any troubles while implementing in between. So this is currently the pattern of data that we are seeing, that we have just created, and you can observe here that we have some missing values in this data set right here that I have just created. This head function also you all can run. I can put this in the chat box. That's great. I can see the responses in the chat now. Everyone just keep on implementing things. It is about what we do parallelly. That is more important. Instead of doing a lot, just do things parallelly. Even if we are doing less, still you will learn a lot. So the first code I have shared again for those who were looking for it.
Excuse me, ma'am. Ma'am, is it possible you can share this collab sheet?
Yes, later on I'll share this collab sheet also. No issues. Once I complete session, then I'll share this collab sheet also. But if you implement side by side, then it will be more useful, because then you can discuss errors.
No problem. We will try best. Okay,
yes,
no problem.
yes.
Okay.
Sheet will be shared later on. That will not be an issue. So head we have seen right here, and I have shown you that we have some missing values. And there is a specific technique in Python to just get a count of your missing values from the data. Because see, currently we have created a very small data set, but this is not a practical case. What is the need to give missing value? See, we are trying to do a missing value analysis. So we need a data set with missing value to understand this. We are just creating a false data set here to understand how to deal with missing values. Otherwise, you can just pick up some filled data set which already have some missing values, and then you can understand. This is the learning process we are doing, nothing else. Otherwise, you will find a variety of data sets in the data columns, whether on the blogs or from the sensors, etc. Missing value is a problem in the data set that we are trying to deal with. So definitely we need to create a data set which has missing values. So a sample just for that I have created. Now, in order to get the count of missing value, there are different approaches that we can follow. For instance, isNull is one method, and we can follow it with the same variable name that we have given for the data set. And if we run this part, this isNull method always gives you output in the form of booleans. You can see true and false. But this may not be always useful. Understand the reason why. Because when we are implementing this thing on a bigger data set, means on a real world data set, you will not have like 10, 12 rows all the time. You will have thousands or maybe lakhs of rows in the data set. And you cannot track everything by using this true and false. So a more improved approach to this is just to get some of missing values from every column so that you can process it accordingly. So we can see here, it says that in every column we have at least 2 missing values. Yes, because that we have created it like. Otherwise, in the real world data set, it will give you count according to that data only. So if you have more, that will be presented to you. So I'm sharing this data set as this small code also. This is to see missing value count in data set. Now, the main part is how we deal with this missing data, because this is just a sample we have created by now. But the main task is to clean your data. That is the first thing we have to learn in today's session, how to clean your data. There are several different approaches that you can follow for this. In literature also, you will find like hundreds of different approaches to deal with missing values. Researchers are always inventing some new techniques. Considering the time limitation of this session, I'll just demonstrate you 1-2 different options that you can use, and other definitely you can explore later on. So I'm using here first method 1, that will be using dropna. This is the first technique. I'm using the name of function that is dropna over here to deal with the missing values. By using this dropna function, basically what we are trying to do is we are trying to drop the rows that have missing values. This may not be always applicable. See, in data science, whatever procedures we have, they are not standard always. Depending upon the data set, the formation of data set, the type of missing values, we choose method to deal with it. Dropna is just one of the methods that we prefer when we have huge amount of missing values in the data set that cannot be imputed or cannot be replaced with a common variable. So better to drop all the columns that have missing values. So that we can use easily. Abhishek sir, I request you to, can you put please that snipper link in the chat box here so that I can access it from here directly. Otherwise, I may have to open the different section over here. Yes, thank you so much. So I'll be sharing the code on the snipper window also. All of you can get it access from the platform right here. So using this dropna method is very simple. For instance, first I'll create a copy of this data. See why I'm creating copy of data, because I'm not willing to apply this method directly to my original data, since I'll be using one more method also. So if I clean it using one method, I'll not have the data again and I'll have to recreate it. So instead of doing my operation on the original data, I'm just creating a copy of it. And then I have a simple method to apply on it, that is a dropna method. And if I run this, you will see how it works. See, we have only the clean data set, and see the index values are not in sequence now. Reason? Because we have dropped some rows from the middle. Like wherever we had missing values, those rows are dropped now. For instance, if I go back, you can see here, we had missing value in this 0th index ID, we had on the 2nd, we had on 3rd, then we had on the 4th. So the same pattern, if we see, 0th is missing, 2, 3, and 4 is missing, then 5 we have, and following further, the same pattern occurs here. So this is the first technique where we drop missing values directly. I'm putting this in the snipper window also. You can get it from there as well. Let me know if you all are done up to this. Then I can show you the second technique to deal with the missing values. This dropna approach we follow when you have a large number of missing value, like more than 30 or 35% of missing values, and we consider that imputing those values will change actual meaning of your data set. So better to drop those rows or columns that have too much missing values. The second technique is Filna approach. So I'll put it here. So we have method 2, that is Filna. And this will help you to fill those empty or nan values by using a specific value. And what value we can use, that is again a statistical significance. It is not always a standard value. We take reference from the stats of data. Sometimes we use like mean based missing value, sometimes we use median, mode, and standard deviation, variance. Plenty of statistical parameters are there. I'll just show you one example. Remaining you can follow on the same pattern. For instance, I'll again create a copy of my data. These are optional things that I'm doing here. You can put it on the original data set also. I'm just creating samples of data over here to avoid recreating data sets or rerunning codes again on the same pattern. So I'm creating a for loop here, since I want to fill the missing values in the entire data set, but with the column wise operation. Understand this fact very carefully. Whenever we fill missing values, we do not use same variable value throughout the data set. Rather, we do imputation column wise. So even if you impute it with mean, median, or mode, you calculate that value for every respective feature or every respective column. So the same we are doing here. I'm iterating through all the columns of my data, and then I'm going to compute the missing values and replace them by following specific mean or median value. So this is my Filna approach. And inside this, again, I have to pass the respective column that comes in the for loop, and I have to calculate the mean of it every time. See what we are doing? Iterating through the columns of the data and filling mean value of the same column in that respective column only, instead of disturbing the structure of entire data set. After deploying this, you will again be able to see head of your data, and let us see all values, means all rows. 12 rows we have in the data, so let us see all of them. By default, head function shows you only starting 5, but if you want to see more, we can put that number right here. And if I run this, let us see what we get. Just a minute, I have a typo over here. We need to iterate through columns over here. So that I'm updating, and you can see now there are no missing values. And there will be definitely a standard value in every column that we used to replace this. So I'm sharing this code right here. You can see we had a missing value at first this position. And then we had at this position and at this position. There may be certain value that is arriving here, this one. And this one, same value, you can see, because we filled it with the mean. Wherever we had a missing value in third score, it was imputed with the mean. Similarly, here also you will see this one and this one, a common value we use to impute the missing values in this particular column as well. So sometimes we need this approach as well. This can also serve your purpose. These are just two options I have shown you, considering whatever time we have. Just two options I have shown you. Otherwise, we can also have the replace technique, where we have a specific value to replace the missing values at specific position. In that case, you can give a specific value, like I want to replace missing value with value 99. So you can do that also. Otherwise, we have some interpolation techniques also, linear interpolation, for example, that will just get through the numbers that we have in the particular column, and it will find the intermediate value by following a linear line, and it will just put that value inside your missing value corner. So these are just a few examples to deal with missing values in your data. Let me know if we are done up to this, and if it is clear that how we deal with the missing value. That was the first problem we have in the data. Just put things in your chat box quickly. Is this mean calculated over all columns? See, this thing I just explained. We are doing column-wise operation, means independent column will be used for mean calculation. Understand this in terms of stats. If you calculate mean of entire data set and replace everything with that mean, it will change meaning of your data set. Reason being, the mean of entire data set will be totally different, and mean of every column will be totally different. So when we have any kind of data set, we need to preserve the statistical significance of every individual column, like this one, and this one. So we always calculate individual mean, median, or mode, and then we use it for the replacement. That is the safest approach we have. Other than this, we can have the machine learning based methods also to deal with huge amount of missing values. That also you will find in the literature. The second problem that we have in data set is, for instance, I'll put it up here, outliers. This is the second big problem that we have in the data set. First problem we discussed in the data cleaning was missing values, that we have just done with the two different approaches. Now we are talking about outliers. So before we implement anything, we need to understand what are outliers in your data. Outliers are basically some data points that stand out significantly from the rest of the data. Means you have a specific range in your data set that you expect, but the observations are way beyond that. Let us take an example of measurement over temperature variable in a specific room. Like you may have installed a sensor in your kitchen area or maybe in your classroom area, and that is measuring temperature. Its capacity is to measure from 10 degree to 50 degree. That is the standard capacity of that sensor. But sometimes you see observation, maybe you have deployed that sensor network and then you are taking measurements for 1 year or maybe 6 months. But when you observe your data pattern, you see that there are some observation with the value 5 or with value 60 or 70, which clearly are out of bound for the capacity of that sensor or the specification of that sensor. This may happen sometime due to some fluctuations in the field environment, some heating conditions may be changing in the field environment that are causing malfunction of your sensor. So these extreme values that are out of bound, they represent outliers. Sometimes we also call them noisy observation. Things that we are not expecting in the data set, but still there are some variations, some errors that are present in the data, and we have to deal with them. We cannot process a data that contains huge number of outliers directly for a machine learning model, because it will deviate performance of your machine learning model as well. So you can have different types of outliers, like we have some global outliers that stand out throughout the entire data set. Some depend on the surroundings, some depend on the sensor fluctuations. There may be outliers due to manual errors. Plenty of things are there. But the more important part is to understand how to deal with them. Again, we have some statistical approaches for that. For instance, for normal distributions or skewed distributions in your data. Now, again, we are talking about some statistical measures over here. Every time I use any procedure in data science, there is always a science behind it. There is no random selection for any method, no random selection for any implementation. We always get inspired from the stats of the data. That is why whenever you learn data science, the first chapter always starts with stats or statistics you have to understand. So at the initial level, we just need to understand the pattern of data so that we can choose a reliable procedure for it. For instance, when we have outliers in dataset, first you need to understand if they follow normal distribution or if they follow skewed distribution. And now for those who are very new to these terms, that normal distribution and skewed distribution. So the procedure is very simple. Normal distribution we also call as a Gaussian curve. So for instance, I'll put it here. When you have a data set that follows bell-shaped curve like this, which has equal portion of data in both sides. This curve should have equal portion, almost equal portion in both sides. And it follows a bell-shaped curve. That becomes your normal or Gaussian data set. Second, sometimes we have skewed data set. For instance, it may be left skewed or it may be right skewed, sometimes even skewed towards negative direction, when it is not equal in both directions. So this is your skewed data set and this is your normal or Gaussian data set. Depending upon the pattern of the specific feature, understand this very carefully now, we are not talking about distribution of entire data set. Instead, distribution of specific columns right here. The operations we always do column wise. We first understand importance of every feature. This feature may have different distribution. This feature may have different distribution depending upon how they are originated. For outliers also, same issue may be there. Each observation or each column may have a different pattern. So we first need to understand pattern of every individual row and column, and then we have to apply procedure on that. So in order to deal with the outliers right here, we have two popular techniques, although you will find hundreds of different techniques. I'm talking here about two standard approaches that most of the time will come into play. One is Z-score based method, and second is IQR range based method. When we talk about Z-score based method, it is basically following the pattern of mean and standard deviation. For instance, this Z-score method, it always works on the normal distribution that we already discussed, means on bell-shaped curve. On this bell-shaped curve, what we will try to do is, for instance, if this is a pattern of your data, and this is the pattern of your data, and inside this, you will follow first the mean value somewhere in the middle of your data set. Then we'll calculate third standard deviation. Most of the time we prefer third standard deviation, that it includes 99% of your data. The statistical significance says that third standard deviation covers 99% of useful data. So what we do is, anything that falls outside this will be considered as an outlier. Anything inside this will be considered as good data. The second approach we have is IQR range. This is for non-normal distribution, when your dataset doesn't follow normal distribution. And I already shown you that it can be a skewed dataset. In this case, we follow IQR, that is your interquartile range, where we find quantile values of data. That is basically 25 percentile and 75 percentile of your data. And based on that, we make calculation like IQR means Q3 minus Q1. Q3 is this and Q1 is this. So it will just try to find the intermediate range first. And then we find the upper and lower bound. Like for instance, here, the upper and lower bound we calculated based on mean and standard deviation value. So here also some mathematical formula you have to apply. So in this case, the lower bound we calculate by using Q1 minus 1.5 IQR, and the upper bound you calculate by following Q3 plus 1.5 multiplied by IQR. This is your mathematical technique. So accordingly, the cutoff values will decide, and anything outside this will be taken out from the data. Sometimes we just try to replace it with the boundary values. There are again multiple approaches. This is just the idea I'm giving to you. Here in the previous case, your formula again, it will be like you have mean plus 3 sigma. That is your third standard deviation, or mean minus 3 sigma, upper bound and lower bound. Accordingly, you can calculate. The same thing you will implement on your Python code also by following the same mathematical approach. So let us do that. First of all, we'll do this operation now on the dataset, the CSV datasets that I have shared with all of you. Before we start that, definitely most of you will need to understand that how we put data on this Google Colab platform. Let me show you a simplified approach for that. See this very carefully, otherwise you will be lost in the platform. First, you have to go to this file icon over here. You can see below this key option, we have files icon. Click on this, and then we have this side portion where some sample data is shown. You have to put your data in this space to be able to access it on the coding platform, because Google Colab directly works on the Google server, so it doesn't have direct access to your system folder. So we need to attach it somehow with your system folder. Either we can drop data here, or we can use dataset from the drive directly. The drive technique also we will learn in coming days. We'll have more sessions for that. The simplified approach I'm telling you here, one basic technique, I'll show two examples. One is drag and drop approach. I'll just reduce this screen size and I'll go to my data folder wherever you have kept your data set. For instance, in my case, I have my data sets in this folder right here. So I can just select my data, drag it and drop it here. It will give you a quick warning. You just have to click on OK. And depending upon how big is data set, it will be quickly available here. This is the first approach, drag and drop. Second technique, if any of you is not able to drag and drop, we can do upload button. Right below this files option, here we have the upload button. You can click on this and it will allow you to browse any of the folder on your system. And for instance, I want to upload these two datasets. All of you may have these three datasets with you because the same folder I have shared with the three datasets. So diabetes, iris, and placement, three datasets I have shared. So we'll just import all of these together over here. Note that the datasets that I'm uploading here, they will be available for the runtime. Those who are using Colab for the first time, understand this carefully again. Runtime means as long as the sheet is active and you have not lost your internet connection, this CSV file will stay here. If you rerun this sheet maybe after a week or maybe after some day, you may first have to upload these datasets again, and then your code will work as it is. This dataset will be lost once you close this sheet. We will learn permanent solutions also in coming days. So don't worry, this is the first day. We are using a simplified approach only. So currently what I have to do is I need this particular file, placement.csv, to work on my outliers. So what I'll do is I'll just load this dataset on the platform. And in order to do that, I first need some libraries. I'll write here the task import necessary libraries. So there are two libraries that I have already imported. You can see these two I have already imported. So they will definitely work throughout the session. I need not to import them again. But I need some visualization libraries over here. Although visualization we will learn tomorrow in detail, so that will be a detailed portion. I'm just introducing two libraries today because I'll need some plot just to show you that how the normal and skewed distribution on data may appear. So just a quick view of those libraries we will do here. Otherwise, in detail, we will do these libraries tomorrow. So I'm using here matplotlib.pyplot as PLT. This is one plotting library. And yes, second one we have is Seaborn. So those who have already used these libraries, they might be aware with the names. So these two libraries I have imported. Very commonly used libraries for the plotting task. Tomorrow we'll be using them for variety of plots for EDA, that is your exploratory data analysis also. Now what I'm doing here is read dataset on which I have to do my operation. So now we are learning one new thing here, how you read a CSV dataset. So those who are very new to this, they will also learn a new concept here, how to get a CSV dataset imported on your Python platform. So we take help from pandas library. You see PD, that is your pandas library. We take help from this. Then we use read underscore CSV. And inside this, we have to put address of the file. Wherever we have placed that file, we'll just put its address right here. So I'll just go back to this place. See this, how we get the address? Just right click on this file and use copy path. Right click on your file, use copy path and paste that path within inverted commas inside your function brackets. And after this, again, you can see the head function for your data itself. And we will see what pattern of data we have imported, this placement dataset with CGPA, placement exam marks, and whether the candidate is placed or not. This is a very simple dataset I have obtained over here. Those who are implementing it side by side, I'm sharing the libraries right here. And this read dataset technique also I have shared. In case if you have started later on and you have not already imported these two libraries, so I'll put them also in the sequence right here so that you import all four, and then only you will be able to read your dataset. Let me know if you all are ready with this dataset on your screen so that I can proceed ahead with the distributions. Thank you for the responses. That's great. So I just hope that everyone is following, and if anyone is stuck, they can help me know anytime in between so that I can just suggest anything if you need. So now what we are doing here is, this is good to see your responses in the chat box. A task I'm inserting here now is, before I choose the technique to deal with the dataset, means before I choose a technique to deal with the outliers, I'll first see if my variables are following normal distribution or skewed distribution. That concept I already discussed with you. So for this, what I'll use is I'll take help from the matplotlib library. I'll be writing multiple lines of code over here. No need to rush with the code typing since I'll be sharing the code. What I'm explaining, that is more important to all of you. So what I'm doing here, I'm explaining it side by side. First of all, I'm just setting up my figure size. This will be because I'll be plotting two figures here. So I'm putting a subplot information. Subplot as same as you create in MATLAB or in any other platform, the same technique I'm using. So first is your number of rows in your subplot, number of columns in your subplot, and then position of the figure that I'm going to plot below. So this I'm going to create as a dist plot. Dist plot means distribution plot that I'm putting for one of the columns in my data set, and the column name I have is CGPA. For this particular, I'm going to create my first plot. Make sure that you follow it with a specific case sensitive pattern, because Python is a case sensitive language. So we have to be careful with that. Now I'm just taking this pattern and I'll be using it for my second variable with second position, and this I'll change to this name, that is my second column. I'll just copy this one and I'll replace it here. And ultimately I'll write here plot show. Let us see what we get. Then I'll share this code with all of you. So these are the two plots that we are getting. These are some warnings we are getting. These are based on if some functions are deprecating or not. If you want to turn off these warnings, that is also possible. For instance, I'll just import warnings over here, and then I'll just filter all the warnings that we can do. And just if you want to avoid getting these messy informations with you. So only errors we can see and warnings we can ignore. So let me run this again, and then we can have the cleaner version of the plot right here. You can see, we can now clearly observe, following the thing that I told you here on the window. This first one is following bell-shaped curve, that is your almost a normal distribution. Second way is a skewed distribution. So on this one, we can apply which technique? Anyone wants to respond in the chat box? Which outlier detection technique we can use for the first one? Anyone wants to respond? We discussed about two outlier detection techniques. That is Z-score based, and second is IQR based. In case of first, since it follows bell-shaped curve, be careful everyone. When we have bell-shaped curve, yes, we need Z-score in that case. We discussed it just now, right here. This is your Z-score based method with a bell-shaped curve. Second approach we had is with skewed dataset, that is this one, the second one. Placement exam marks are skewed. So this one will follow IQR based method. Now we are clear. First is your Z-score, second is your IQR. So let us start with the procedure right here. For this is the reason why I have picked up this particular dataset, because we'll see both patterns in the single dataset over here. That is why I have shared multiple datasets with you, because we need to understand the patterns. So accordingly, variation in dataset I have added over here. So what I'm doing here is, first of all, the method I'll write here is use Z-score method on CGPA variable. First of all, let me just print limits, or we can just try to see what are the limits based on your third standard deviation. So for instance, I'll write here highest allowed limit, that is with your CGPA column, and we will definitely calculate its mean. That is the formula we are following, the formula that I have shown you already on the whiteboard screen. If you remember, we had mean plus 3 sigma. So I'm just calculating standard deviation of the same column over here. Note that operation is going column wise. So I have selected column for the mean also, and for calculating standard also, the same column I have selected right here. Same I'll do for the lower part. So I'll just convert this one to lowest allowed. And this one I'll replace with minus, because this was a formula that we studied recently. Plus will provide the upper limit and minus will provide lower limit. So these are our limits right now for the upper and lower portion. So this is how we are going to cut off your data. But maybe if you want to know how much data, or maybe if you have some data outside this boundary or not, that is also an interesting part to do. So let me add one more thing. First, I'll share this portion with all of you. Okay, the plotting task also I'll share. This is available in your snipper window now, those who want to implement it. And then printing limit also I have shared. So maybe if you want to know that if my data set is following anything outside boundary or not, I'll use a simple function that is statistical description of data set with describe. You can observe here the mean of your CGPA data set is this. The min value is 4.89. The max value is 9.12. So you can clearly observe that there are some entries that are outside your required boundary, because the minimum value in our case we have suggested is 5.11 by using the statistical significance, and higher we have suggested is 8.80. But what our data set currently have is 4.89 and 9.12 as max and min values. So clearly we know that there are some outliers in the data, and definitely we need to trim them off. So in order to do that, what we can do simply is we'll trim it off by following this limit only. I'll take it further to a simplified code. Check outlier values that are outside bound. So this is just an optional thing I'm doing here. If you want to see that what kind of values we have outside bound, then I'll just try to get it right here. I'm just trying to give you a clear picture of these outliers basically. So this is for the upper bound, or if some values, I'm using or operator, or if some values are on the lower bound also. So CGPA with value less than 5.11. So these two limits I have applied, the upper limit and the lower limit. Anything above this or below this, that I want to print right here. Let us see what we get. You can see there are plenty of values that we can see outside. At least of these 5 values we can see directly that are outside this bound, and definitely we may need to remove them. So I'll share this also with all of you, how you can see the bound, outside bound values quickly, because in our data set there are limited. Otherwise you may have like sometimes thousands of outliers are also present in the data set. So accordingly we may have to deal with them as well. This is just a beginner task we are doing over here. Now comes the major task, that is to trim your outliers. We have just seen that these are the out of bound observations. So what we can do now is I'll just trim outliers. And for this, what we can do is we'll just follow this boundary, but with opposite signs. So I'll create here a new df. I'll store it inside a new. So outlier was outside that limit, but the required data will be inside that limit. So I'll just change this greater than and less than symbols. Opposite I'll do, because outside these is your outlier and inside these is your actual data. So I have just replaced symbols right here. So now we can see your new data, and let us see what we get as an outcome of this. Now you can observe the majority of values will be within your bound only, depending upon how we have set your boundaries. For the CGPA ranges. Let me just check if we have any typo in this. This one we have up to this. Okay, and operator I need to use here. Or operator in the previous case, and operator here, because now we are cutting down the middle portion. Then only you will just cut short through the values. So this is to trim your outliers. Just the operator also I have changed. And after this, again, if you try to describe your data set, you will see that the upper and lower bound is changed now. Now the operation will be on new df because that is the recently created variable with the data. You can see now your min is 5.23 and max is 8.62, which is within our boundaries. The boundaries we have already observed. Let me know if this is clear up to this level. Then I'll show you the other method also. This is about applying filters with the upper and lower bounds directly. Again, I'm repeating one thing, that every time in data science, we have different approaches to follow based on pattern of data. Whatever we are learning, this is just a journey you are getting through with the data science. Otherwise, whenever we have a practical implementation, always we go with the literature and the stats of that particular data, and then we choose operation. Collab sheet, don't worry about that. I'll share it later on. After finishing session, it will be available with your course coordinator and they will provide it to you. So first technique we have learned, and the second technique is your IQR method. And that will be applying here on the second variable that we had in the data. So for instance, when we apply this IQR based method, we generally recommend to use box plots because box plots give a clear vision of your IQR range. For instance, first I'll use here a plotting technique. Apply box plot for variable. The variable name right now is placement exam marks. And I'll take help from my Seaborn library to create a box plot right here. And inside this, I'll choose my data variable, that is placement exam marks. So let us see if we can find any outliers in this data. See, this is a box plot right now. And this is a very interesting image you will find to understand presence of outliers. For instance, I'll take it here. This is what we are getting as an outcome. If you want to see it on your screen also parallelly, I'll share this for the IQR method. See what we have inside. With the box plot structure, it generally gives you the boundary values and anything that lies outside the boundary that we have here and here. These represent outliers. And I told you in the beginning, outliers can be present on the upper side, on the lower side also. They can be high scale values, they can be low scale values. So in this particular case, we are finding them on the higher side. There are no outliers on the lower side. This is clean. But here, outside this boundary, we are finding some outliers. So we need to get rid of these basically. Whenever you observe any data set, if you find any such things, you have to either take reference from the stats of your data or from the literature that what you can do with these outside bound values. Now, let us see how we can apply the method on this data. Very first thing, find IQR that I told you in the discussion also. So we need 25 percentile of your data and 75 percentile. So what I'll write here is percentile 25, I'll give it a name, and inside this I'll put my data, that is your placement exam marks is my data name, and then we'll just apply quantile 0.25. This is to get your 25 percentile of data. This is the lower boundary of your data. For the box plot, the lower bound of your box plot, we can say. The same we will do with your 75%. So here I'll change it to 75%. And finally, I'll get my IQR range by using percentile 75 minus percentile 25. So this will bring out your IQR range. You can even print it just to see what you are getting in the outcome. I'll run this part. And this is the IQR value it is providing us right now. So I'll share this also to find IQR. Now the next part is, as we discussed in the theory also, that we have to find the upper and lower limit. So for that, I'll insert the code cell right here, upper and lower limit. So what we'll do is, first I'll just put my bound right here. So it will be percentile 25 plus 1.5 multiplied by IQR. This is what we discussed in that graph also. And opposite to this, the lower bound I'll try to find by following percentile 25 right here with a minus sign. So this will bring out your upper and lower limit. So the cutoff limits basically we are trying to get from here. So I'll just copy this part and you all can implement it. After this, we can apply the same approach that we have used earlier. Like you have used the boundary values here also. Like this also you can apply upper and lower bounds that you have received. For instance, I'll just take this one and then I'll just place it here at this position. You can use, there are other ways also. First, let us check if this one works. Otherwise, I'll tell you other way out also for this. Lower limit and upper limit. And I'm creating one more data set right here. So this is our outcome right now, based on how we have reduced your data variable. So the limits we have applied right here with the upper trim and lower trim. Okay, this is on the CGPA. By mistake we have applied. Just let me just correct it. We have not changed the variable name. That may be a problem here. We need to change the variable name. Since I copied it from the top, this is why we should not copy a codes. We should do it always ourselves so that we get right things in the outcome. So now it is implemented on this middle one. I'll just correct this in the shared document also, right here. So this is the second technique in detail we have learned, that is with your outlier detection. Let me know if we are clear up to this. Thank you very much for the updates in the chat box. And now we are moving to one more topic of discussion here, that is your data sampling. Sometimes like we have a huge data set in hand, but we just need to see few samples of it. There are so many reasons to do sampling. Sometimes just to see some samples of data set, sometimes to process a mini version of the data set, and many other reasons also. Here, I'm just going to demonstrate you 2-3 different ways of sampling that are commonly used in data science or while dealing with your real world data files. So the very first approach that you all might have heard is random sampling. This is the simplest technique we have in learned in the mathematics also, in the stats also, random sampling. And here we need to understand how we implement it on real world data. So for that, I'll be using again this placement data. So I'll just get my data head here again just to see if my data is ready inside this. Yes, my data, the original data is here because I have used the copies of this data set already. So the original one I must have right here. Now the first thing I'll do is random sampling. And for that, the technique is very simple. We have a very precise code. First, I'll write here sample size of 5, for example. I'm using a very small sample. You can use any range of sample here. Then I'm creating a new variable for data RS, that is data with random sampling. And inside this, I'm applying sample function with the predefined sample size. Or you can put the sample size here also directly. That is also your choice. I have defined it already. In your case, you can do it as per your choice. And then we can just see if this data RS contains some samples or not. And you can see these values are from random indexes. They are not in sequence. Some random index it has taken. If I rerun this, you will see it again from some other index values. That is actually the meaning of random sampling, and we are able to prove it here. Random sampling means we are giving time to your data for all the observations to get opportunity to be a part of your random sample. This is how we do random sampling. Sometimes you need to get a smaller version of data from a big ocean of data. Although here we have a very small data set, but still we are just learning the approach. Let me know if it is working fine on your system. Then I'll tell you other approach also that you can use for the sampling. Thank you very much. The next one we'll use here is random sampling we have done. Then we'll use stratified sampling. These are the common approaches to deal with failed data. In stratified sampling, if you go with the simple theoretical factors, it is basically creating some subgroups of your data, and from those subgroups, we just try to get the based on various factors from those subgroups, we try to extract relevant data. And these stratas can be made based on specific feature or specific group in your data set. So there are different versions of this stratified sampling also. I'm using here a very simple approach. What I'll do is, we have a library called sklearn already available in your Python platform. And inside this, we have model selection module, from where I'll get one existing function that we call train test split. This train test split we use very widely while training your machine learning models, while training your deep learning models. This is a very commonly used approach. Why we do this? To split your data set into training and testing sets. So training set we use to train your model, and testing we use to evaluate your model performance. So because we need random shuffling between these. So sometimes we use stratified techniques for that. Sometimes you use shuffling techniques. Sometimes you use random techniques, different methods inside. But train test split itself is a very famous method for splitting your data set randomly. Randomly means based on the stratified sampling technique that you can apply, or sometimes shuffling technique you can apply. We have sub-parameters inside this function that you can declare. For instance, currently I'm using a strata based on the last column of my data, that is placed. This one you can see whether the candidate is placed or not placed. So that pattern I'm following from here. So data placed is my strata target. So what I can write here is column used for stratification. This is my column. Depending upon what type of sampling you want to do, you can choose a column from your data set. Then sample size, as per your choice. For example, I'll use 8. You can give any number. And then we'll use a sample over here, and other parameter we'll put inside this, because this returns multiple parameters. So I'll use a dash over here. I'll just take some random samples over here. Later on, I'll show you what other parameters also we get from the train test split, because we have other sessions also. So when we'll be building some model, I'll show what in return we get from train test split. Currently, I'm just getting some samples out of it. So I'll just use train test split over here, pass my data inside this, then display how much size I need for my train. So I'll write here sample size that I have already given as 8, or you can give the number right here. And then stratified technique I'll give is my strata. That is already right here, or you can give this right here also. That is your choice. Then let us visualize the sample. I'm just trying to explain every part of the code so that if anyone is beginner, they can understand it easily. You can see again some random index values we have obtained from the data, but the main factor is that it gave equal weightage to this data placed. You can see there will be 4 samples from one category and 4 samples from other category of placed, like 4 ones you will see and 4 zeros you will see. So it gave equal weightage to both. I'll share this with all of you so that you can imply. The idea is to stratify based on the column that we have selected for this purpose. So it gave equal opportunity for both entrants. Those who are planning to work on image data sets, don't worry, this is just the first session we are dealing here. We have more sessions in the workshop, and there we'll be dealing specifically with the image data set also. We'll use CSV version of the image data set also. We'll use direct image version also. There will be plenty of options. So don't worry, we are going to discuss all those things in coming sessions. Let me know if we are clear with the stratified sampling right now. Thank you very much for the update. And one more technique in the sampling I'll discuss here is systematic. You might have heard about this sampling also. Systematic is where we follow a specific pattern, like maybe after every 10 numbers or maybe after a specific regular interval, we will take sample. That is also a technique. It depends on what kind of population we have. Generally when we have a very large population, then we follow this systematic sampling, and we put a sample size of something value, and accordingly we keep on extracting data from there. So a step size we have to mention in this case. So what we'll do here is, for example, first I'll calculate population size from my data, and that I can do by calculating length of my data. So population size equal to length of data. That will help me to understand how big is my population and what kind of step I can create. Then, for example, sample size I'll use 100. Means from my data set I need 100 samples. Then based on these two values, the exact length of my data and sample size that I need, I can define my step size, which will be a simple approach: population size divided by sample size. So this will help. This will be basically floor division, not a normal division, because we need a round of values. So I'll use double bar over here. So this will give you floor division, the round of values directly instead of getting decimal values out there. So round of values from the division we'll get here. So after this, I'll just apply this on to get my indices. np.arrange function. I'm taking help from NumPy library. Starting from 0 to the population size, that is the end value, following the step. Understand this carefully again. How I'm getting the indices. Indices means your index values. How I'm getting them? I'm just using a sequence starting from 0 till the end of the population size and the step size that I'm calculating from here. So because this particular data set has a length of 1000, there are 1000 observations, and the sample size is 100. So means my step size may be 10 over here. So accordingly, after every 10, I'll be getting a new observation in my sample. So let us see what samples we'll be getting from here. Data.ilock technique I'll be using here to bind my indexes. The index values I'll bind by using ilock technique over here. These are some mini functions I'm using in between, considering that many of you might have. We started from 0, so population size should be, I'm getting some comment right here, just let me see, should be -1. There are different ways that also you can do. In NumPy, we have -1 option also when we do slicing. That also you can do. But since I have already calculated my population size, so that will also work because I already know what is the length of my data set. So both will work easily. You can even put here length of data, or you can put some indexing value, some slicing value. Multiple options are there. You can do that. Just let me see if I have any typo over here. Okay, I need to write 1 R only for arrange. So this is my sample right now, and you can see after equal space of index values, I'm getting it up to 990. So 100 samples it calculated with a size or a step size of 10. Let me update it right here. So this is one more sampling technique we have just learned. Let me know when you all are done with this implementation. If anyone is stuck anywhere, I'll definitely wait for it. Thank you very much for the updates. So before I go ahead, we'll just wind up whatever we have done till now. We started with the data cleaning procedures, and there we talked about two important problems that we can have in data set. One was missing value handling, second was outlier detection. For missing value, we worked on two important methods, that was drop-na approach and fill-na approach. And then on the outlier side, we worked again on two important approaches, that was Z-score based method and IQR based method. We learned how we apply different Python libraries to just create a statistical summary of your data and then understand the min and max values. Then we apply certain procedure to improve your data quality. And after that, we just switched to another topic, that was sampling. And inside sampling, we learned three different approaches that included random sampling, stratified sampling, and systematic sampling. You will find many other approaches also. I'm just giving you a summary of the most commonly used options. Now we are switching further to another section of the discussion today, that is pre-processing techniques. See, these pre-processing techniques, cleaning techniques, they are very extensive in nature. Like, even if we study them for several days, still will not come to an end. There are unlimited methods available in these categories. We are just trying to get a dip into the knowledge of ocean inside this. We are just trying to learn the basics, and then we can implement this knowledge with different variations further. So in order to deal with this, first of all, I'll be using some, inside data pre-processing, some feature scaling method I'll let you know. Before we apply feature scaling, we need to understand what is the purpose of it, why we need to apply feature scaling anywhere in your data. So let us get a quick idea of it. Many times when we get a data set from the field environment, you will rarely find a data which is precisely designed between all the observations or all the variables. Sometimes we have dominating features. Some features have very low rank, some features have very high range, and they keep on dominating each other. For instance, let us take a quick example over here. Like, I have installed some sensor network somewhere, and from there I'm observing, one is my temperature reading, second I'm getting maybe humidity reading, and third maybe I'm measuring a gas like CO2. In general, what pattern you will find for this? Like, temperature variation you will find from maybe 10 to 50, just taking a random example, degree centigrade. And then humidity, for example, we are getting from 20 to maybe 80% RH. And CO2, maybe we are measuring from 500 to maybe 3000 ppm. So this may be a common range that you have inside data. Just let me go through a comment that we are getting here, maybe some questions. What does underscore represent in stratification example? Without underscore, 992 columns returned. Okay, we are just trying to get samples only right now. When I was implementing this, then also I told you that this train test split function returns multiple variables in the output. I'm just using sample as my main variable, and others I'm just putting in a hold right now. I'm not using them right now. Tomorrow, when we'll have another case study, there we will learn what are the different outputs obtained from this train test split. Then I'll put 4 different parameters by removing this underscore right here, because I'm not there. I'll not be putting anything on hold. Currently, I just need the sample based on the sample size applied here. So I have taken just one parameter out of this. That is my training sample. The others are on hold. So that we will discuss in detail also. This is just for now. As a beginner, what we are learning is just the sample only. This part we'll do with the case study. So coming back to this, yes. So for instance, this is the data set as an initial pattern we are getting. But what is the problem in this data set? See, these are very low scale values. This is a high scale value. So what happens in actual when we try to train a machine learning or deep learning model with this kind of data, the high scale features will start dominating the low scale features, and they just try to deviate your model performance. So majority of time, what recommendations you will get from the literature is to scale down all your features to the same level. And those scaling down approaches are a part of data pre-processing. We call it feature scaling or feature normalization also we call sometimes. There are some feature standardization techniques also, multiple names we give based on what method we are choosing. For instance, what we can do is we can bring all of them to an equivalent range, maybe from 0 to 1. All of them can come to an equivalent range so that they just remove the dominance on each other. But now the question is that if we bring them down to 0 to 1 range as a common for all of these, what will happen with the statistical significance of each variable? So for that, what we do is we do not put this 0 to 1 randomly in your data. Rather, we follow a trusted and a proven statistical approach only that helps you to map down your high scale values to low scale variables. How that we have to do? There is, for example, one technique that we call min-max scaler that by default takes your values down to 0 to 1. Understand this carefully how we do this. For instance, we have a range from 10 to 50 for temperature, and we want to scale it down from 0 to 1. So 10 will be mapped to 0, 50 will be mapped to 1, and everything within will fall within 0 to 1. The same will happen with this one again. The minimum scale value is 500, the higher range is 3000. So again, it will be mapped 500 to 0, 3000 to 1, and all the intermediate values will fall within. This is how we do scale down approach, or the sometimes we call normalization or standardization approach. This is just a simple example of it. There are many other mathematical calculations that you can follow inside. But the idea is to bring down your feature values to same range so that they stop dominating each other. So what we are doing here is inside this, we are inserting one more technique, that is data pre-processing right here. I'll just insert it here, and then the feature scaling method that I'll tell you first is your min-max scaler, for example, that we just discussed, that it by default takes your data from maximum scale to the minimum, that is 0 to 1. So I'll use same placement data set again. So I'll put here df6, any random variable name I'm using here. You can use any other variable name also. I'm creating a copy of that data because I need the original version of data again later on. So I'm using operation on the copy of this data only. And df6 I'll use for the operation. So if you want to again recheck the head of data, that is optional. You can do that. This is the data on which I'll be using my normalization. Again, there are several statistical things that you have to follow. We don't apply normalization or scaling on these kind of variables because they are already on 0-1 scale, on minor scale. We generally apply this on the continuous values that are on the higher range. But I'm not doing that selection right now. That is just for your understanding because we don't have time to split data and then apply procedure. But the clarity I have given to you that we generally apply normalization and scaling on the continuous variables instead of categorical variables like this. So what I'll do here is I'll just tell you how we apply the method. So for that, I'll first write here using min-max scaler, and here Again, I'll take help from sklearn library and I'll go to preprocessing module inside sklearn, and from there I'll get my min-max scalar function. So from sklearn preprocessing module, I'm getting min-max scalar function. I'll initialize this min-max scalar function with its default values. See, whenever we initialize a function with empty brackets, means we are using its default values only. We are not making any manual change. And by default, it reduces your features from the 2, 0, and 1. Means between 0 to 1. We can change that. Maybe you want to do from -1 to 1 based on the stats of your data. That also you can do. Those parameters you can discuss with variety of data variations. You can update them based on the data variations. I'm using the simplest approach here for your understanding. Then I'll get the scaled data set. Now I'll just fit this scalar over my data set. So I'm using fit_transform over this df6. And I'll show you one interesting thing over here. When we apply this directly on the data set, you will see what we get in the outcome is a numpy array. The outcome of this min-max scalar, or many approaches that we apply on this data, they are numpy arrays. But when we are operating on the data frames, you generally require output in the form of data frame for clear understanding. So what we'll do here is we can convert this into a data frame also easily. Let me show you a quick technique for that. I'll share the code also based on that. So pd.dataframe I'll use here outside this directly. I'll use pd.dataframe outside this. Now let me show you one more part. If I run this, it will be converted to a data frame, but the column names are missing. You can see the column names now are 0, 1, 2, but we were working on these column names. So I have converted to data frame, but the numpy array was not having column names. Array doesn't have column names. And I tried to convert it back to data frame, so the column names are not preserved. So in order to preserve them, what I can do here is I'll write here one more parameter, that is columns, and that I'll get from my original data set right here. From df6, this is the variable I'm using right now. From there, I'll get my column names, and then I can put it back here, and let us see what we get. You can see now we have preserved the column names, and your feature values are now between 0 to 1. You can see I have worked on this one also, although this is not necessary, but just to save time right now because we already have very less time. So just to show you the technique, how we implement this, I have shown this. All of them are now on the lower scale. Earlier, they were having these kind of values, you see. Now everything is on the lower scale. So let me share this with all of you. This is how you deploy min-max scalar. If you have not created dataset copy, that also I'll place here. You can create copy of the data and then apply your min-max scalar. Let me know if you are done with this. Then I'll show you another technique, that is standardization technique for the same thing, for reducing your feature scale. We do standardization also. That is again another popular technique you will find. Just update me if we are clear up to this. Thanks for the update in the chat box. Okay, great. So we are moving to another technique right here. After min-max scalar, I'll do here standardization. And this standardization again is based on standard deviation and zero mean of your data. So we just need to calculate the mean of your data and then a standard deviation, and how we do the scaling down in this case. You can understand it clearly now. Because instead of taking limit of 0 and 1, now I'll take limit with mean and standard deviation. So first I'll calculate mean of my data, that will fall in the middle of your data value, and then I'll calculate standard deviation of it. So if maybe this is the standard deviation limit, for example, the third standard deviation lower and upper bound I'm getting here. So anything that was 300 and maybe 3000, that will be mapped to upper and lower bound within this range that we have decided for the data set right here. Now everything will be within this range. So this is another approach. So in case of min-max scalar, you may have values from 0 to 1. But in case of standard scalar, you may have values on the higher range, sometime on the negative side also, because it completely depends on the stats of your data. If the standard deviation is going into the negative side, then your scaled down values may also go into negative side. So completely based on the data pattern. So let me show you the technique here. Again, very simple. I'll follow one more copy of my data to just observe the new pattern. And instead of just plotting it, we know already that what is inside this data. Let me show you the simplified technique, how we apply it. So I'll just copy this part. I'm just using this to show you how simple things are. I'm just changing my technique right here. And then I'm changing my method over here. So I have a method name standard scalar that I'll have to use. The second approach is standard scalar. So I'll just replace it right here. And everything else I'll keep as it is. I'll change my variable name. That is df7 right now. So this should be fine. Means why I have done it like this, just to show you how easy it is to implement different methods. You just change name of that method and you are ready to get a new data set out there. You can see, I told you that now there can be some negative values also, because now we are following standard deviation and mean value. So wherever the mean of data is following, accordingly, the standard deviation will be calculated and there may be some negative values as well. So this is your second approach with standardization. Let me know if we are clear up to this. Thank you very much for the updates. So after this, we will switch to another important part of data pre-processing, that is feature encoding. Now, let us first understand what is feature encoding, why we need it, and what are the purposes of doing this. I have shown you that in your data set, we can have two common variations. Your columns can be numerical in nature, and sometimes your columns can be even categorical in nature. A simple variation you can understand from here itself. In this particular data set, these two are continuous columns, purely numerical columns. In numerical columns, we generally consider discrete values or your continuous values. The second technique is categorical data. So this one is basically a categorical data that has class-based information, like 0 and 1 are two classes right there. There may be multiple classes also, like maybe 0, 1, 2, 3, 4 classes we can have. This is currently in the form of numerical values. You can see 0 and 1 is basically a number-based value. But actually, this is representing a class-based value. Class is two groups of data. Several times you will have data set that is not already encoded into these zeros and ones. Rather, the data is in some textual information. Like for instance, you have data set obtained from some patients or maybe some hospitals, you have obtained medical data set, which has one outcome variable, healthy, unhealthy. So this is a text-based information. So it is not encoded by default. It is healthy, unhealthy, healthy, unhealthy. They might have written it like this based on the patient observations. Or like diabetic or healthy, diabetic or healthy. So that represents your categorical data with two classes. But in order to feed it to a machine learning model, it is better to convert this data set into numbers first. Majority of your machine learning data set will understand numbers better instead of deploying some string values into the model. So what we have to do is we have to encode those categorical values first, encode them into numbers, and then get a clear version of that data for a model training. So for that, we have plenty of different encoding techniques. Since we are already on the verge of session, I'll just show you one simple technique over here for future encoding that you can deploy, because this is again an important thing that you may have to learn. So for this, I'll use this iris dataset, for example, because this dataset contains one categorical feature. So what I'll do is, now all of you know, we can just import this dataset. I'll use this inside df8 variable. And how do we import? We use read CSV. And within this, we can implement your copy path, and we will place that path right here. And inside this df8.head, just to see how this dataset appears. So I'll just see this. You can see this last variable is currently in the form of categorical feature. This requires some kind of encoding. If you just try to see more values of it, you will see. This is a very famous dataset. All of you might have gone through this dataset. This is currently organized into specific species. So in the starting, we are looking at this iris setosa values only. But otherwise, if you want to see the unique values inside, that also we can do. So currently my variable is df8, and inside this I'm trying to get my species, and inside this I have unique values inside. Let us see what we have. So it says that we have these 3 unique values inside this species column. So I'll just put it here for all of you. You can get this dataset as well. And then check the unique count. Means we have 3 unique values or 3 classes in this particular column of your dataset. Now, if I have to encode this, maybe I have to encode this into zeros and ones again. So one simple example I'll use here is label encoder. A very popular encoder we have. So again, I'll take help from my sklearn library, and from preprocessing module, I'll import label encoder. There are plenty of other techniques also again, but it completely depends on which one we want to use based on the stats of the data. Currently, I'm just using one sample over here. The technique is same as the previous methods we have used. First, just call your function and then initialize it with the default parameters. If you want to make any changes when you get proficient with data science, definitely you can add parameters. But as a beginner, we can start with the default values directly. Then I'll use this df7 dataset directly. And I'll just operate only one variable, that is my species variable. So I have df8 as my current variable. Yes. So instead of operating on entire dataset, I'll just operate on species variable. And inside this, again, I'll just fit my transform over the same variable on which I'm doing this operation. So I'll insert it here. And finally, I can print head of this particular data set. Let us see what we get. You can see now the species are encoded into zeros and ones. And again, if you want to see the unique values, that also you can do. So df8, and inside this I'll put species. And I'll just use my unique method with this, and let us run it. So now you can see 0, 1, and 2 are the unique values. So this is how we sometimes have to encode features based on if they have categorical structure or string-based entries, and you want to make your dataset ready for the model building. So this is the technique you can use in that case. We are now getting a cleaner version of data. And on the same note, you have many other encoding techniques, such as we have one-hot encoding, we have dummy encoding, we have ordinal encoder, like hundreds of different encoders you will find in the Python libraries, and you can apply any of them just to see how your dataset works.